Hi, welcome to Lesson 7.4, Trigonometric Identities. The goal of today's lesson is to use equivalent trigonometric relationships to prove that an equation is an identity. And the reason why we're going to do this is to continue practicing manipulating trigonometric expressions, which will help us solve more complex problems in future sections of this course. And of course, there are a great many real-life examples that we can be using, or that we will be able to solve as we go along. Okay, so just to begin, we want to take a look at some of the identities that we have seen previously. So the quotient identity, we see sine theta is equal to y divided by r. That comes from the unit circle. And if we were to rearrange this, we find that y equals r sine theta. Similarly, we can do the same thing with cosine, where that equals x over r. Multiplying both sides by r, we get x equals r cosine theta. And therefore, we know that tangent of theta is y over x, which is r sine theta divided by r cosine theta. The r's cancel, so we're just left with tangent of theta equals sine theta cosine theta. And also then, because the cotangent of theta is the reciprocal of tangent theta, then that means that since tangent theta is sine theta divided by cosine theta, therefore the reciprocal of that would be cosine theta divided by sine theta. Now moving along to the Pythagorean identity, we know that the Pythagorean theorem is x squared plus y squared equals r squared, which also is the formula for a circle centered at the origin. And we know that y is equal to r sine theta, and x is r cosine theta. Now we're also, we realize we use that r, the radius of the circle, is 1 unit, hence the unit circle that we'll be using. And so therefore, if we substitute cosine theta in for x, we get cosine squared theta. We substitute sine theta in for y, we get sine squared theta. And the radius is 1, and 1 squared is just 1. Okay, and then if we were just to rearrange this, sine squared theta plus cosine squared theta equals 1. Now then, if we were to rearrange this formula by isolating cosine squared theta, we would get 1 minus sine squared theta. And then we go back up here and we isolate sine squared theta by subtracting cosine squared theta from both sides. We get sine squared theta equals 1 minus cosine squared theta. Then to get to the reciprocal identities, we start with this identity here, sine squared theta plus cosine squared theta equals 1. And if we were to divide all three terms, i.e. divide both sides of the equation, by sine squared theta, we would divide sine squared theta by sine squared theta, which gives us 1. Divide cosine squared theta by sine squared theta, we get cotangent squared theta. And 1 divided by sine squared theta gives us cosecant squared theta. We can do the same thing with starting with this Pythagorean identity again and divide all three terms, or both sides of the equation, by cosine squared theta. And we would then get sine squared theta divided by cosine squared theta, which gives us tangent squared theta. Cosine squared theta divided by cosine squared theta gives us 1. And 1 divided by cosine squared theta results in secant squared theta. Okay, so all of these things are going to be part of our toolbox when we start looking at these trigonometric identities. Now, new formulas that we just learned a few days ago: the compound angle formula, and from that we found the double angle formulae. So these will also be things that we can use to help us when we are solving these trigonometric identities. Okay, so that's just a little review. You want to keep that handy, this sheet handy, so that you can refer to it as we proceed. So what we're going to do is we'll move along to page 2 here. And there's a few little rules of thumb or guidelines that you might want to follow when we're solving or proving trigonometric identities. The first couple are, well, the first one's actually fairly straightforward. You want to try to identify which side is more complicated, because if we simplify things, it's easier to simplify a more complicated side of the expression than a non-complicated side. So identify which is more complicated, and then we try to simplify as best we can. Try to simplify down to sine and cosine as much as possible, because that's kind of bringing things down to the base functions. And then step by step, what you want to do is kind of refer back to the other side that perhaps you're not working with, and see if you have then attained equality, showing that the two sides of the identity are equal. One other thing that you just might want to note is that you cannot cross the equal sign. Unfortunately, the book that we use does cross the equal sign when they solve these, and that is a no-no. So I'll show you the proper technique in a couple seconds, but you want to make sure that you do not cross the equal sign. Okay? So sit back. Actually, no, don't sit back. Strap yourselves in. Take a deep breath, because here we go. Okay, so take a look at this first example here. We've got cotangent x sine x equals cosine x. We want to prove that this is true. Okay, so any time that we're trying to prove a trigonometric identity, it is true, but we just have to prove it. We have to show that it's true. Okay, so there aren't going to be any tricks here. We're not going to say to prove something if it doesn't work. Okay, if it's not true. So first thing, like I said before, we don't want to cross the equal sign. So what we're going to do is we're going to state what the left side of the equation is. And in this case, it is cotangent x sine x. And then we want to state what the right side is, and the right side is cosine x. Okay? Now, it's not too difficult at this moment to see which one is the more complicated side. Neither of them are super complicated, but we see that the left side, of course, is marginally more complicated than the right. So we'll start working on this one. So if you can have your identity sheet handy and kind of take a look around and see what kind of relationships you can find. And actually, I think the other one, actually, there's a couple there that I haven't listed here. And they're also quotient identities. They're more like they're reciprocal identities, basically. And so they're basically, remember that cosecant theta is 1 over sine theta, and secant theta is equal to 1 over cosine theta. Okay, so those are two other ones that we didn't have listed here, which would be useful to us. Okay, so maybe you could jot that down on your sheet, and I'll just continue back here. Now, hopefully you found here, we've got cotangent theta that's involved in that identity that we're working on. We see that cotangent theta is cosine theta over sine theta. And also what we want to realize, we want to simplify down to sine and cosine as much as possible. So here's cotangent x. We realize that that is cosine x divided by sine x. And that's being multiplied by sine x. Then we see, well, we got sine x, and that's divided by sine x. So these two things can cancel out. And then what's remaining is just the cosine x. And if you want to look up here, we see, oh, nice. That is the same thing. Therefore, that equals the right side. And a little therefore statement wouldn't hurt. Therefore, cotangent x times the sine of x does indeed equal the cosine of x. Okay, first one down. Let's take a look at the second one. So here we've got something a little bit more complicated than the first. We've got 1 minus cosine squared x times cosecant x equals sine x. All right, so the left side is 1 minus cosine squared x. And times cosecant x. And the right side is sine x. And so, obviously, the left-hand side is more complicated. So what I'd like you to do right now, could you please pause the video and take a look back in your sheet and see what we can do here to simplify this, to kind of write it in a different form so that it will help us cancel things out like we did over here in this first example, so that eventually we can find sine x. So this may involve rewriting these things in terms of just sine x and cosine x. Okay, so pause it now and come back in a couple seconds, okay? Okay, so I see that we've got 1 minus cosine squared x, and if I were to flip back here, we see that I've got 1 minus cosine squared x right here, which means that 1 minus cosine squared x actually equals sine squared x. And while we're at it, I also realize that we got cosine or cosecant theta, and that equals 1 over sine theta. So 1 minus cosine squared x is equal to sine squared x, and cosecant x is 1 over sine x. Okay, and if I look back over here, I see things might be looking up over here on the left. So that gives us sine squared x over x. And sine squared x is nothing more than just sine x times sine x. So I can cancel out one of these sine x's and that bottom one, and that will just leave me with sine x, which is the same as the right-hand side. Therefore, 1 minus cosine squared x times cosecant x does indeed equal sine x.